In order to help you understand standard deviation, I'm going to go through a couple of different PowerPoints. The first one is from the University of Connecticut, talking about the normal distribution bell curve associated with standard deviation. So in other words, how do you graph what's known as standard deviation? Standard deviation is a numerical value that you calculate, and so this PowerPoint presentation is going to show you how to graph that calculation. It's easiest to understand if you use the example provided herein, where you take 30 teachers and you graph the shoe sizes of those various teachers. So the first person had a 10-inch foot, and if we put that as a bar, you'd see that one person has a 10-inch foot. Then our next subject has a 9-inch foot. And as you keep going, you have a 6-inch foot, 13-inch foot, another 9, so now we have 2 people with 9-inch feet, a 7, an 8, a 10, and so forth. If you continue to graph this, you'll see a pattern that comes into play. That pattern is that more people have feet that range in size in the mean, or in the middle versus the extreme ends. So we have this pattern that's emerged, and we want to talk about this pattern in a way that we can analyze the data. So if we were going to connect each bar graph, you would see a line that looks like this. And you can actually smooth out that line, and you'd see that it forms pretty much a bell curve, with more of the population having foot sizes in the middle of this graph, and fewer people on the extreme low and extreme high ends. This is called the normal distribution bell curve, and it's the focus of the rest of this presentation. When you see it, you got to think about the data beneath it that supports this bell curve. It'll help keep your head wrapped around that. So here we've got quiz scores. Along the x-axis, you see points on a quiz. Along the y-axis, you see the number of students that earned that number of points. The mean is 17. So if you add up all the scores and divide by the total number of scores, you'd have 51 students that took this quiz, and the average score, or the mean, was 17. The mode, which is the most frequently occurring number, if you laid out all the numbers, you would see that 17 occurs more frequently than any other number. And the median, which is the middle number, if you laid them all out on a line, the middle number is 17. So in a normal distribution bell curve, the mean, which is the average, the mode, which is the most frequently occurring number, and the median, which is the middle number in the entire range, will all be the same value. Here, it's 17. There are a number of factors that can change the shape of your bell curve, mainly the width and height of the bell, and we'll discuss that in a little bit. That's a mathematical formula that you don't have to worry too much about. So in a normal distribution bell curve, you have what's called standard deviation values. And a standard deviation is going to be a value that you calculate, and it's going to be above and below the mean. So one standard deviation is represented by all of the values above the mean and below the mean by your calculated standard deviation value. And in bell curves, 68% of the data falls within one standard deviation. And if you go up by another standard deviation and down by another standard deviation, you'll end up with 95 of the values, 95% of those values are in the range of 2 standard deviations. So I'll talk to you more concretely about this in a moment. 3 standard deviations is going to be 99% of your data. So if you go above and below the mean by 3 values that are called standard deviation values, you'll find that 99% of your data points fit within that range. This is just showing you a website which is really helpful. If you click on this, it takes you to a site where you can actually calculate the area under the curve. You can change some values, and you can determine what are the odds that your values, what's the probability that your values will be in this range, what's the probability that your values will be in either of these ranges, and so forth. It's a pretty cool website. If you click on this, or you just type in the URL, you can go and fool around with that, and you can use this when you're actually analyzing lab data. That's a little bit more advanced, so we can talk about that in class. So we get different, as I said, shaped bell curves. A small standard deviation is going to lead to most of the data points are going to be closely grouped around the mean, whereas a large standard deviation, many of your data points are going to be away from the mean or deviated from the mean. So the narrowness of the bell curve is determined by the size of the standard deviation value. So in this case, down here we have two different data sets. The first one looks like this, and the second one looks like this. So the first data set has a pretty small standard deviation, and the second data set has a very large standard deviation, but they have the same mean value, meaning that the middle of the graph, the average value, is the same in both. Here we have the same standard deviation value, so the shape of the first bell curve and the second bell curve are the same because they have the same standard deviation, but the middle of those graphs are different because they have different means. And here in this third example, we have different means, so the middle of these bell curves are at different points, and they have different standard deviations, which means the height and narrowness of the curves are different as well. So it's really useful, and you'll see this a lot when you see standardized test scores, and we can talk about that if you want more in class. When you see that you are in the 90th percentile, what does that mean? I can talk to you more about that if you want. So here we've got an example. Let's say that you've got a math test, and this example shows you how a bell curve would look for that particular math test. And on another test, you've got a different set of data, and so you can compare the data. It allows you to examine your data in an analytical way. Now, not all bell curves are going to follow the normal distribution. Sometimes they're skewed. So in this case, there were more individuals in the population that had larger feet than smaller feet. This is called negatively skewed or left skewed bell curve. And the skew refers to where the tail is. So the tail over here is on the left, meaning that fewer values are on the left, so it is considered a negative or left skew. Sometimes you'll get a positively skewed or a right skewed curve, in which case there are fewer values on the high end. When it's skewed, your mean, median, and mode aren't going to be on the same value anymore. When it's skewed, the mode is still going to be the highest point because it's the most frequently occurring, so it's always going to be the top of that bell curve. The mean, which is the average, is going to be closer to the tail, and the median will be between where the mean and the mode are. So here's an example of what that would look like. Okay, so in this case, the mode is the most frequently occurring number. That's why it's the highest point on the graph. The mean is the average value. That's why it's over here a little bit, because there are some values that are over to the left side. And the median is going to be the middle of your range. Here's an example of a right skewed graph with the same idea. Now I want to take you through a second tutorial. This one talks more about how to calculate standard deviation. So now that we know how to graph standard deviation, let's talk about how you can calculate standard deviation. So in looking at this, and I use this PowerPoint from another IB teacher, you have 10 students in 2 different classes, and each class had an average score on a test of 81.5%. So if they have the same averages, can you say that all the students did about the same? No, you can't. And the reason is, just because it's an average value for the class, it doesn't mean that the distribution of the grades was the same. So let's talk about this in a little more detail. If you were going to graph this out, in this graph you would see that the lowest score was about a 72, and the highest score was around an 89. 2 students scored an 85, 2 students scored an 80, and so on. But the other class that took the quiz, the low score was down here in like the 57 range. The high score was like in the 98 or 99 range. So we've got a very different range here and a very different distribution of our scores. However, the mean value for both graphs are the same. So just talking about the mean and the range isn't good enough. We're going to actually talk about the deviation from the mean as a way of describing our data. So in this case, we've got the average value denoted in green and the range in red, but we haven't really been able to talk about the distribution, which is going to be shaded here in yellow. So in order to do that, it's a calculation called the standard deviation. It standardizes the values so that you can describe them in an appropriate manner. If you have a large standard deviation, it means that the numbers are very spread out away from the mean. If you have a small standard deviation, it means that the numbers are very closely grouped around the mean. So here's the individual scores for the first class of students that took the test. The average was an 81.5, and the graph looks like this. So we're going to discuss the standard deviation value. So we're going to measure each individual value and its distance away from the mean. So here's our first value, 72. How far away is 72 from 81.5? And the answer is negative 9.5. You're going to continue to do this for every individual data point, and you're going to tabulate it in a data table. You then square those distances. So 9.5 squared is 90.25. Negative 9.5 squared is 90.25. Negative 5.5 squared is 30.25, and you're going to continue to do that for all the values. You then add up all of your squared deviations, and you get a total here of 214.5. You then divide by the number of your sample minus 1. So in this case, there were 10 students that were sampled. 10 minus 1 is 9. So you take the total of your squared deviations and divide by the number of samples minus 1. And you get a value here of 23.8. Finally, you're going to take the square root of that value. So the square root of 23.8 gives you the number in red here, which is 4.88. And that is your standard deviation. So let's do it again for the second class. Here's the values for the second class. The average we know was an 81.5. So we have to take 57 away from 81.5 and we get negative 24.5. Take 65 away from 81.5 and we find that it's a negative 16.5, and so on. Then square those values, add them up, divide by the number of samples minus 1. There were 10 students sampled, so that's 10 minus 1. Take that value and use the square root, and the square root of that gives you the standard deviation of 15.91. So how does that look when you're comparing the classes? They had the same average value, but they had very different standard deviations. Team A, the first class, has a very narrow bell curve because it's a low value for standard deviation, whereas Team B would have a wider shaped bell curve because it has a much larger value for standard deviation. So if you were to take Team A's score, the average of 81.5, and go up by 4.88 and down by 4.88, 68% of the class would have scored in that range. If you were to take the second class and use their average value of 81.5 and go up by 15.9 and down by 15.9, that would be 68% of the values in that class would fall within that range. So again, I know this takes a little time to get your head around, so we have practice problems and so forth. Feel free to contact me and we can discuss this further.